Thank you, Julien. So just quickly about us, we are Jeremy and Nicolas, both software engineer at QuantStack. So QuantStack, if you don't know, is a company that work on open source project for scientific computing. So for example, Jupyter, CondaForge or Mamba. So here we'll speak about AI. We all know that AI is moving very fast in the recent years, and especially with a large language model. So there are new models added frequently. Some of them are specialized in code completion or code generation, and can be included in IDE, like VS Code or Cursor. And some provide some command line interface to be usable in a text-based environment or directly in a terminal. So I'm thinking about Codex, for example, from OpenAI, or maybe Claude from Anthropic. So what's the state of AI in Jupyter? For today, there are mostly two main projects that we can talk about. So the first one is Jupyter AI, which is incubated under JupyterLite project. So this project, I think it started 2 or 3 years ago. The current stable version allows code completion, have a chat to interact with the LLM, the language model, and allow some magic command to be used directly in the notebook. And the development version, which should be out soon for a stable version in maybe at the end of the year, also add some agent. So the agent basically is a LLM with some tools that can interact with your environment, and can also communicate with MCP server. Again, MCP server, very quickly, because Jeremy will talk about it, but it's a way to have some tool on a remote server and to use these tools. And also the new version of Jupyter AI will work in real-time collaboration. So that means that the language model will be seen as a regular user in a collaboration system. And another project we can talk about is Notebook Intelligence, which is an independent project and is working only with GitHub Copilot, because I forgot to mention that Jupyter AI allows to use many providers. And Notebook Intelligence also is able to use agents and call MCP server. So, but this project needs a Jupyter server to work, because everything is working in the server side. So what about the integration in the browser, and how can we use AI model in the browser, and especially in JupyterLite? And also, we'll try to discuss a bit about the future of AI in Jupyter. So here is the plan. We'll have a quick look at JupyterLite and remote AI models. Then we have a lot of example and a lot of demo of the use. So the current state of the use of AI model in the browser, and discussion about it. So what is JupyterLite? I don't know if some people were there just before, or maybe will be there after, because there is another topic on JupyterLite. I think it's the same room. But very briefly, JupyterLite is a JupyterLite distribution that runs entirely in the browser. So that you just have to download some assets, some statics file, and you will have your JupyterLite distribution with your, including your kernel running with WebAssembly, and all the application of the JupyterLite application will run in the browser. So as you can see in the image just below, so this is the documentation of NumPy, and they use a JupyterLite Python console on it. To integrate the AI in JupyterLite, we start a new project called named JupyterLite AI. Easy to to remind. So now we will present you some feature we have with this project. The first thing we wanting to have was a chat which can communicate with a language model. Currently, we have that chat widget that can communicate with, by default, with a model from Anthropic, from OpenAI, from Mr. AI, and from Olama. And more model can come with extension. Jeremy will show some of you in the browser, and there are also so anybody can bring an extension to use more models. So we can start a quick demo and see if it works. Here you have JupyterLite. So as I said, it's a static web page that including JupyterLab, and we have a chat that we should request. Yeah, here we request. So I think I don't know which model is. So it's Mr. Oh yeah, it's Mistral. Mistral Medium is the model we requested. So then we have code completion. So I don't know if we can use the same one. Okay. Okay, cool. Thank you. So the code completion will provide you some suggestion on in the notebook. So for example, if I open one, and yeah, let's try. I say. So you can see the suggestion, and the completion has some context about the notebook and the current cell, and so you can it should provide some interesting information. Basically, it depends also on the model. Some models are better than others to provide some completion. And yeah, now I will let Jeremy show you some more features.
Thanks, Nicolas, for the intro and the first demos. So we have, so we wanted to explore a bit more with what we can do with AI from the browser. And nowadays, I think everybody expects some kind of agent somewhere. So we started to play around with this, and so we added support for tool calls in this chat here. So if I clear and I ask the model to create a new notebook about pandas and matplotlib, it's just going to do it. And here we can see which tools it's calling, which input, and what the result of the tool call is. And it goes on and on and on. So it adds more cells, not only code cells, but also markdown cells. So we see it working like this, so it's nice. And actually we can also do some other work at the same time because it's working on the actual notebook document in a browser. So we don't need to have a notebook with the focus. And then if we want to execute all of the cells, we can just say, okay, clear all of the outputs. Okay, here I didn't even execute it, but clear all of the outputs and then run all of the cells in the notebook. So here what happens is a tool call, which is about discovering what commands are available in the browser. And JupyterLab exposes like many different commands. And here if we look at the result, we see there are 437. That's a lot. So you can think of commands like, I don't know, like an action you can perform on the UI, like creating a notebook or changing the layout. And here it tried to find something about executing cells, and it found one. But here now we have this box asking for approval. So that's something we have also started to experiment with, is a way to ask for approval when we may perform some actions that maybe harmful to the user or execute arbitrary code. This is configurable. But here, if we approve, then the agent is going to execute everything. And now we see the output. So that's pretty much agent mode. What is nice about this is that we can also start implementing different components separately, such as showing a diff for a cell. And here there is a package called JupyterLite cell diff, which is just specialized into showing a diff under the cell. So if I go back here and I say, let's see, yeah, this cell here is using pandas, but let's say we want to move to borders. So here I say the current cell, so it's getting the cell info tool, it's using it, and then let's see what happens. Yeah, so it replaced the content of the cell, and right after showed the diff. So here as a user I can just collapse everything if I don't want it. I can also reject or here accept and accept the new code suggestion. So yeah, so with this approach, what is nice about running things in the browser is that you can have access to any JupyterLite commands, even the ones coming from extensions and third parties. So we saw the discover commands tool, the execute command tool. So those are pretty much you could say the only tools you need with your agent to be able to perform actions on the UI, which is quite interesting because now if you want, you could also say, let's see. Yeah, I think I had a prompt here. I can ask, okay, toggle the right area, which is here, and show the about dialog. Both are controllable via command, so it just discovered them and executed them. So you can go a bit further with this. So if you have an extension that provides commands, let's say, for example, creating a CAD file and 3D models like we saw in the previous talk, we could just say, create a new JCAD file, and then when open, build a new chesspawn step by step using the available JupyterCAD commands. So here we're kind of nudging the model to use the commands. Finally, a demo effect. Okay, let me see if I can just do, I think. So it's also nice that in the browser you can just refresh and start, clean. Yeah, okay. This time it created the file without an error. And now it's going to use the JupyterCAD commands to build this chesspawn. And I can interact with it at the same time and have a look what is happening. Yeah, I'm not saying that the result is good. It's just that it's nice to see it working for me, but yeah. So yeah, that's what you can do, and I think yeah, thank you. I mean, all of the credits goes to the people who worked on JupyterCAD, because in our case we're just coding commands, so it's pretty easy. And we are not even coding it; it's the LLM doing it, so it's even less work for us. But yeah, so yeah, the AI space is moving super fast, and what came up, I think about a year ago, was this thing called MCP, for Model Context Protocol, which is a standard to have a more like a plug-and-play way for bringing tools, resources, and prompts to LLMs. It was started by Anthropic, but I think most everybody picked it up afterwards. So it's possible to use it on real servers, but in the case of the browser, it's a bit more complicated today. But there is still one use case of the MCP servers, which is interesting to us, is remote MCP servers. And those are servers that don't run on our machine, and they don't even run on the browser, they run somewhere else. And here, I can show you actually live what it looks like. So we have this section here, and there's this thing called Deep Wiki. Maybe some of you have already played with it. So you can have like a wiki style for your Git repo. So if we enable it here, we can say what are the latest, let's see, changes in Jupyter JIS. And the fact that we give it GeoJupyter JIS triggers this tool call here, which is not implemented in the browser. It's something that lives outside. Okay, it didn't really give me what I wanted, but yeah, never mind. I think the most important is this part here. So it has like more, this MCP server can also have like more targeted queries on the Git repos. But yeah, I think the main point here is that you can execute tools that are not local to your computer. So I think WebMCP is still a thing. I think we have something about that at the end. Maybe we can skip for now. Now comes the fun part with LLM in the browser. So what if we could run some models in the browser? That means no dependencies on servers, because here we're still depending on the providers. So we need to make API calls to the providers to get some replies back from the LLMs. So one aspect of the LLMs in the browser, which is very interesting, is everything around privacy. So you don't have anything that goes outside of your computer, not even outside of your browser. So it's really good if you don't want to start like leaking stuff to companies in other countries. And currently there are two main projects. One is called WebLLM and the other one Transformers.js. So they both take the approach of combining existing models to WebAssembly, and they also have a way to use web GPUs, so the inference is a little bit faster on the browser. And here I can just show you, I will show you a quick demo. This time is just a screencast, because the important thing was not necessarily in the interaction with the LLM, but more like what happens when you run such model locally. So here with WebLLM, we use Llama 3. And what happens if you want to use such model is that you need to pay the cost of downloading. I think in the case of Llama, it's a bit more than 1 gigabyte. So of course I was not going to do that on the conference Wi-Fi. So here the video is a bit sped up, and you see that once it's downloaded, it's cached in your browser, and then you can come back to your browser and play with the LLM, and nothing goes outside of your browser, which is quite nice. It's of course not as powerful as the latest cloud model or Mistral or anything that like, or the frontier models, but it can still be useful for some cases. Which brings us to built-in AI. Built-in AI is the idea of what if you have models, you don't even have to download them. Okay, you have to download them once, but what if they ship with the browser directly? So as of today, there is Chrome and Edge that have like a version of that. Chrome is Gemini Nano and Edge is 5.4 Mini. And what that means is that if you open your DevTools, you can do this language model.create, and it gives you a prompt API, and then you can just prompt it. So this API is still, very new, and so I think, yeah, this is the one we're using, prompt API. But there are a couple of others that are quite interesting and more targeted to special use cases that are already available in a stable release of Chrome. But the prompt API is still behind flags, so we need to enable some flags in Chrome. And what I wanted to show, like the kind of use cases I wanted to show here, was that sure, it works with code, but it's also interesting that you can use that for other things, such as, let's say I have the notebook about fractals, and in my notebook I have this image, but it doesn't have any alt text whatsoever, which is not good for accessibility. So here, if I do right click, I have this generate alt text with Chrome AI. I can do that. And here it's just using the Chrome AI built-in model. It's passing in the image as input, because now these models are also multimodal, which they take input and output, images and audio files. And here it replaced the markdown tag with the description of the image. So it's basically just image recognition in the browser. And the other one was about audio I wanted to show. So if I...
Hello, PyData Paris. How are you all doing today? I hope you are enjoying the conference and beautiful Paris.
So I generated this with the 11 labs just to have like a demo audio, and now I can generate the transcript. So at least you heard it. Now we're gonna check if it's correct. So now it generated the transcript, and this is also all running in the browser via Chrome AI. So I'm really excited about this because for now it's still behind flags, it's still very new, but we can imagine that in the future, maybe it would become available to most devices, and then you don't even have to worry about setting up API keys or making calls to the outside. It's just right there. Yeah.
Thank you, Jeremy. So yeah, about built-in AI. The main advantage is about privacy, because there is not any request to any remote server. All the data stay in the browser, so it's quite private. But there are some limitations. So the first one is model size that you have to embed. It can go from 200 megabyte to 22 gigabyte for Gemini, I think. And so you need to download the model at least once before using it. And it requires some good hardware to be really usable. Also, there is some MCP server MCP that can work with it, which is quite good, and so it should be better in the time. Yeah, and so now another challenge we had with in-browser AI was about the secrets. So I will go quick with that, but the thing is that as soon as you have all the data in the browser, so to call the API like OpenAI or Anthropic or whatever, you need some key, and it's a challenge because the first solution is to store the key in the browser. Like that, you don't have to populate it again when you refresh the page. But of course, this is unsafe. Another way is to not store anything, and again, when you restart your browser, refresh the page, you have to give it the key again. And we start working on a Jupyter Secret Manager, which is a way to link a key to a remote server. So we don't have too much time, but you can take a look at this project. And also we thought about using a proxy server to keep the API key on the server instead of the browser. So what's the next step in Lite? We'd like to be able to integrate a command line with a JupyterLite terminal to be able to call a LLM with command line. Also, we'd like to have some real-time collaboration in the chat, and maybe to be able to call several models at the same time, and to make them interact. And very quickly, what we'd like for the next step for the AI in Jupyter ecosystem. So there is a really nice discussion, you have the link there, about building some component that can be used for any project, AI project in Jupyter. So we're talking about front-end component, but also a server component or even kernel component. Also, all the extension could get the JupyterLab command better to have some description and some and maybe mostly some description to be able to use it from an LLM. And we could hope in the future some hybrid workflow using some server and browser LLM and yeah. And that's it. You have all the reference for the presentation. Thank you.
Thank you. We have some time for questions. Is anyone? Yes.
Hi, Jeremy. Is there a way to configure the web LLM in order, for example, to get some temperature or logic processor or different things to configure the LLM?
In the case of WebLLM or
in particular in WebLLM and Transformer.js?
Yeah, for now we just build this very simple model parameters, but it's not meant to stay like this. It's too simple, and I think we had a previous version which had which made it possible to configure way more things, but sometimes it's like super overwhelming because you can configure everything. So we have to find like a good trade-off on what you want to expose to users, normal users and also power users. So I think this will evolve for sure. Yeah.
Great, thanks.
Thank you for the presentation. Just a quick question. In terms of providing context to either WebLLM or in-browser AI from your Python packages or whatever you import, is that feature or functionality available to basically be able to get some context from the packages that you're using?
So here when we say something, when we ask something in a chat, we can also use this attachment window, and if you select a file here, it gets attached and it's provided as context to the request. And there is also a way to do this. So you can drag and drop a cell, and let's say I want you to explain me what's happening in that cell. So this is the way it works when it comes to adding more context. But here everything happens in JavaScript. It's in the browser, so there is no it's not like we're doing anything from the notebook. It's happening, outside of the notebook. Yeah.
Top levels?
Yeah, I think it's mostly top level. It's not going to look at the everything that this package provides. It's just going to know that we use that package. Yeah. But you can imagine having this deep wiki integration, and then you can say, I want information about Matplotlib, and deep wiki will return you more information about how to do something with Matplotlib. So you can have this kind of gluing things together, to add more context. But context is a tricky question, because if you add too much context, then it's a lot to process for the LM, and it may give you not a very good answer. It's tricky to find a good point.
One last question.
That's very impressive. I was wondering about the effect of such interface on students, on beginners, and also about the effect on energy consumptions locally on your computer and also on servers, if this is multiplied by millions of JupyterLab users.
Yeah, I can't give you a number about energy consumption. I think it's tricky to measure. So there are two questions. The first one is the effect on, you mean people getting started with Python, for example? Yeah, I think it's tricky. I find it very useful. If you want to learn about fractals, you can just ask it questions, right? So I don't know. I know it's a topic being discussed right now, in education. How do you make use of these super powerful tools so that people can still learn things and not just depend on them? But then about the energy consumption, it's interesting because I think it's the same question we had with JupyterLite in the beginning. Was like when you move the compute to the to the user, then it doesn't run on the servers anymore. It runs on the browser. It's always a matter, I think, of trade-off. Like if you have it on the server, then you need maybe more bandwidth to also send your data back and forth. So yeah, I think it's I don't know. I can't tell you like how much it's using like in terms of power. Maybe there are ways to measure that. Nowadays.
Thank you, Jeremy and Nicolas. Please, let's have another round of applause.